All right, we're continuing our video with solving equations. Now we've got some word problems in front of us. Word problems require us to find the important information, and oftentimes we're going to have to read through the problem multiple times to be able to do that. I also like to draw pictures as much as I possibly can to help me have a visual to stay organized. So I recommend that you do that too. I'm going to work out how I would work out a couple of problems, and hopefully that'll make a lot of sense to you here. All right, our first one is going to have a nice visual because we were talking about the length and width of a rectangle. So I'm going to go ahead and sketch us a rectangle in this space to get us started. So in a rectangle, you got four right angles, but your length and your width are not necessarily the same, just like in a square. So early on, I'm just going to call that the length and call this the width. L is my length. Look at this. Try that again. All right. L is my length and W is my width. But the challenge right now is that that's two different variables. And as I work through this word problem, I'm going to try to do my best to get these to be the same variable. So when I solve my equation, I'm no longer dealing with two different variables. So stay with me and hopefully I'll be able to expand on that just a little bit. All right, so right away, the length of the rectangle is 6 feet greater than the width. The perimeter is 40 feet. What is the length of a rectangle? All right, so right away, the important things that stand out to me in this is we're talking about a rectangle. We're talking about length. We're talking about width. And we're talking about perimeter. All of that are things that you should be, even if you don't write those down to point them out, you can circle those words, or they should certainly be adding to what your picture says. Keep in mind that the perimeter of a rectangle is all the sides added together. So remember, the opposite sides in a rectangle are the same. So really, you're looking at length plus width plus width. That's how you would find the perimeter of a rectangle. So really what I'm going to have to do is figure out what these L's and W's are so that I can actually end up setting up some sort of equation and working through this. The perimeter is 40, so it's all going to add up to 40 for us. So in order to do that, we're going to have to set up an equation to solve for what's missing. Because right now I don't know what the length or the width is. Okay, I'm going to read this statement to you one more time, and I'm even going to highlight it. The length of the rectangle is 6 feet greater than the width. So it's almost like it's going to explain what the length is using the width. So watch how I write this. The length is 6 feet greater than the width. So it's the width plus 6 more feet, because 6 greater is 6 more. So the length is the width plus 6 feet. That's 6 feet greater than the width. Hopefully that makes sense to everybody. Well, notice by me making that statement there, now that says L is equal to W plus 6. That means everywhere I see an L, everywhere I see length, I could put width plus 6 or W plus 6. I could substitute that in, and then I'll only have W's in my equation. So that means my perimeter, instead of being L plus W plus W, I'm going to replace all the L's, W plus 6, W plus 6, and then I'm going to keep my W's. And now, again, I don't have two different variables. I've only got one variable. So I could combine like terms and try to set up my equation. Remember, my perimeter is 40. So everywhere I see a P, I could put that 40. So I know about the 40. And I'm going to just try to simplify a little bit on the right side and combine like terms to make my equation a little bit easier to deal with. 1, 2, 3, 4 W's. So W plus W plus W plus W is 4W. 6 plus 6 is 12. And look at that. I've got an equation to help me solve for the width of this rectangle. So 40 is 4W plus 12. And now I just solve. So I'll go ahead and solve here. I'm going to try to get everything away from my W because I'm solving for W. What's the opposite of adding? It's subtracting 12 from both sides. And that's going to leave me with 28 equals 4W. 4W means multiply by 4. So how do I unmultiply? I divide. So I multiply both sides, or sorry, I divide both sides by 4. 28 divided by 4 is 7. And 4 divided by 4 is 1. So 1W is just W. So when I solve, I get that the width of this rectangle is 7 feet, because that's our units up here. All right. So now, just to make sure I don't end this problem too soon, I also need to figure out what the length is, because it asked me what's the length of the rectangle. I know what the width is, but I need the length. Remember, we know from this statement right here that the length is whatever the width is plus 6 feet. So I could just simply substitute right into that the length is the width, which is 7, plus 6. Well, 7 plus 6 is 13 feet. So my length is 13 feet, and I've now solved my problem. It's very tempting to end that problem after you figured out that W was 7, but make sure that you've answered what they've asked you to answer. So if they say find this, make sure you find whatever that is. Here they asked for the length, so we had to know what that length was, and we've got it right here. Okay, one more example with you guys, and then I'll turn you loose and let you do some practice on your own. Okay, all right. Same thing. If we could draw pictures, we'll draw pictures, but at the very least, we're going to identify any of the important parts of this and try to come up with our equation and make sure we identify what they're asking us to identify. All right. Mike can buy 5 small pizzas and 1 drink for the same price as 3 small pizzas and 5 drinks. Same price. Well, what's another word for same? Well, that would be equal. Okay? So that's telling you the equation right there. He's telling us that 5 small pizzas and 1 drink is equal to 3 small pizzas and 5 drinks. All right. Right away, we're going to need to figure out each drink costs is $1.25. So we don't actually have to find that. We have to find how much does each pizza cost. All right, so let me get rid of this drink cost because we actually don't need to figure that out. I misspoke. We need to figure out how much each pizza costs. So let's start like we did previously and name our variables. All right, I'm going to just use P for pizza. And so we're actually going to do cost of pizza. So every time we see a P, we're actually talking about money. And then drinks, I'm going to use the D for the cost of a drink. Well, the good news is that I'm not going to have to actually figure that out because I already know that that is $1.25. So when I go to write this equation, I'm not going to need D, which is great for me. That saves me a lot of work there. All right, so Mike can buy 5 small pizzas. So 5 pizzas, and what mathematical operation is and? That would be addition. 1 drink for the same price equals 3 pizzas and plus 5 drinks. Okay? So hopefully everybody could see my equation and how that works out with that first statement right there in the word problem. So right here for our parts, that's where we named our variables. Name your variables for your important pieces there. Your total cost, that's what we're looking for in the pizza, not necessarily the total cost of each because we won't really know that. But our equation was The 5 pizzas plus the 1 drink is supposed to be the same as 3 pizzas and 5 drinks. Okay, so we don't really have a total here since we're setting these two statements equal to each other, but because it is an equation, we can solve it. So we're going to go ahead and try to solve that right now. Okay, so there are 5 p's on my left side, 3 p's on my right side. I'm going to try to get all my p's on the same side. There's more p's on the left, so I'm going to go ahead and subtract 3p from both sides. Now, some of you might be asking me, why did I know to subtract 3p? Well, 3p is positive. So positive numbers act like they're being added. So what's the opposite of addition? Subtraction. Okay, so 5 minus 3p is 2p. Bring down my 10 because it wasn't not 10. Look at my, having a hard time with my handwriting. 1d, because nothing was added to it. 3p minus 3p is 0, so it's no longer affecting my problem. But I am left with that 5d, or the cost of 5 drinks. To try to get the p's by themselves, I'm going to get rid of the d's from the left side. What's the opposite of adding? It's subtracting. So I'm going to subtract 1d from both sides, and that's going to give me 2p. My d's cancel on the left side, and 5 minus 1 is 4d. All right, 2p equals 4d. Now you're like, oh, that's difficult because that's two different variables. But remember what we talked about way back at the beginning of this problem. We don't actually have to worry about d because they already gave us the cost of what each drink is. So they really save us on that one, or we wouldn't have been able to do this problem. So now I'm going to substitute in, instead of a d, $1.25. So 4 times 1.25. Now, some of you can do that in your head. Some of you will grab your calculator and you'll do that. Either way is fine with me. 4 times $1.25 ends up being $5. So then I just want to make sure I solve for p. So I'm going to end up, excuse me. Now I'm going to end up solving for p by dividing both sides by 2, because 2 times p, or 2p is 2 times p. So to get rid of multiplication, I have to divide. So that's going to end up with p being 5 divided by 2, or 2.5. So that means each pizza costs $2.50. And that is what they asked me to solve for. So I actually don't have to plug back in or anything. I just found what they asked me to find, $2.50. So these two problems that I shared with you are a good challenge to be able to organize yourself, find your variables, and set up your equation. I continue to encourage you guys to draw pictures, identify those variables so that your equation makes sense. Good luck.